This is new drawing and net ID is ZN2036. I'm doing question 1 in homework 4, and let's start. In this question, we know the relationship between y and x, so we can draw this function first. X, y, and okay, then from the finger we can know y could be -1 to 2, and so we can conclude that the distribution function of y, it will have two eta. When y is greater than 2, and 0 when y is smaller than -1. Okay, then we should divide this finger into many situations. And first, when y equals to -1, and here we need to know the probability of y equals -1, and from the function we know this is equals to the probability of 2 equals x greater than 2, and this can be read in this way. Okay, and we know this is the density function of y in -1. Okay, and then when y greater than -1 and less than 0 is here. Okay. The distribution function y equals to, this is easy way, so I will write it directly. Okay, here we know this is the distribution function of y in this scope, and we need to get the density function in this scope. We can just use this way. Okay, it's very easy to get the density function. And the third part is y equals to 0. Okay, and use the same method. Y equals 0, probability of Okay, we can get this from finger. Okay, here, and write it in another way. This is the density function in 0. Sorry, here is y 0. Okay, and next next part is y greater than 0 and less than 2. Here is probability and we can from finger we can say x equals 0. Okay, and this is 0. So in this part, the density function is 0. And next part, y equals 2. This is the probability of x less than 0. Here, this is the density function of y in 2. So we can just write them together. Okay, I will write it. Okay, this is the second part. And this is the distribution function of y and the density function of y. We can also write it down 1 minus fx. But here we should pay more attention to the impulse function. Here is an impulse, so I need okay, and we can get actually we can get density function from the distribution function. There are many ways to get it, but actually it's the same way. There are same ways. Okay. Here is the point because so we need the impulse function. And next part, Okay, the part from 0 to 2, here the density function is 0, so we put it into otherwise. And now we can we can draw the finger. And the distribution function, 0 minus 1, here is 0, and in minus 1 we have an impulse. So here this point is 1 minus fx2. Okay, and then minus 1 to 0, it will be, here we can see 1 minus fx, 1 minus y. And in 0 we have impulse, so here it will be this way, and this point is 1 minus fx 0. We can see that in this part, and we get the value of here. If it can be 0, it's 1 minus fx 1. Okay, and then add the impulse in 0, so we can get the result. And we know when y equals to 2, the distribution function will be 1. So here is the impulse, and here is 1, and this part is fx 0. So we get the finger of distribution function. And next, density function. From here, we can draw the finger from here. Minus its impulse, and the area is 1 minus fx2. Okay, and from minus 1 to 0, here is x 1 minus y, and when y equals to 0, here is an impulse, and the area is fx1 minus capital Fx 0, and this part is 0 and 0, 0. When y equals to 2, it have impulse, and area is capital Fx 0. And now we solve this problem. Thanks for watching.